Welcome to our foundation channel from class 10th. The chapter number 9 is tangents and secants to the circle. So I'll explain the basics or basic fundamentals from this chapter in this video. Every concept, few sums I'll explain, remaining you can practice from the worksheets. So I'm providing the link in description below. So based on from that you can find the worksheets and practice, right? First, let us see the basic of this tangent and secant. What is the tangent? What is secant? What are the properties and formulas based on this? This is the circle from center to any one of the edge of the circle is the radius, right? And a line segment or line. Just if we take a line segment, if you draw the line segment by touching the center of the circle. Through center, if you extend this radius, if a line segment is drawn through center of the circle, this is the diameter, this. So it's the diameter and it is the radius. So diameter is exactly double to the radius. Radius is half of the diameter. Next, if a line segment is drawn by touching 2 points of the circle, not from the center. So this is the chord. This is the chord it is. So, and instead of by touching the line segment, just if you draw the line, by touching 2 points of the circle. If you draw the line, which touches the 2 points of the circle, this is the secant. So radius, diameter, and this is the chord, and a line is joining 2 points of the circle is a secant. And same secant slowly if you extend to the edge, it will touch at only single point, right? Now if a line is drawn by touching it only 1 point of the circle, only single point of the circle is a tangent. So a line is touching at single point, 1 point of the circle is tangent, 2 points of the circle is secant, right? This is about the tangent and secant. Next, when you come to the properties, and this is the center, right? If a tangent is drawn where the coinciding this radius and the circle, if we draw the tangent, always tangent and radius are perpendicular to each other. So through center, the point of contact of this tangent and radius is exactly perpendicular to each other. Okay, let us take this AB is the tangent and this OC is the radius. They are perpendicular to each other. This CO is perpendicular to AB. So remember, tangent and radius, the point of contact, is exactly perpendicular to each other. Now let us take any tangent you draw. So if you draw the tangent, where it touching, from there you can join the center. They're exactly perpendicular. Okay, remember this. Now based on this property, we can solve few problems first. Find the length of unknown side if the known that PQ is a tangent. So here is a RQ. This is tangent and P is the center. So according to the property, this is the 90 degrees, so perpendicular. So it's a Pythagoras theorem you can see here. PQ is 60. So 60 square hypotenuse. So let be x. This is 60 square is equals to 11 square plus x square. You can use Pythagoras theorem. 60 square minus 11 square. And x value you can find out. So I'm not solving. Just properties, radius and tangent are perpendicular to each other. From this you can find out the x value. Right? Same way, let us see one more sum. So PR is let be x. They mentioned this is the tangent. This dotted line is tangent. P is the center. So always tangent and radius is the point of contact are perpendicular to each other. It's a 90 degrees. Account the property in triangle PQR. 90 degrees. No, this is the hypotenuse. So 13 square is equals to x square plus 12 square. Then x square is 13 square minus 12 square. We can use a square minus b square formula even here also. Like 13 plus 12 into 13 minus 12. A square minus b square formula. A plus b into a minus b. So this is 25 times 1. So 25. X is equals to 5. Right? If it is Pythagorean triplet, accurate value, you'll get it. Okay, this is the regarding tangent and radius. Now some questions. After once perfect all these pages and few questions I'm giving in this page. So measurements are given, you verify it's a tangent or not. Actually, to say this is tangent or not, it must form a right angle triangle. To show it's a right angle triangle, you have to show it's a Pythagorean triplet. So 15 square is 90 degrees, right? 15 square is 9 square plus 12 square. If exist, so this is a tangent. So 225 is equals to 81 plus 144. 81 plus 144 is 225. Yes, it is equal. So therefore is a tangent. Yes. If it is no, if it is Pythagorean triplet, it's not Pythagorean triplet, you can say it's not a tangent. Okay, both ways you can practice from these pages. Right. That is the basics regarding tangent and secant. And next important properties regarding combination of this tangent and secant. I will show three properties. First one, okay, one, two, three. Let me show here. Two chord intersecting each other internally. This is intersecting internally, right? Now let us take this is the AB and CD are intersecting internally at P. Then rule is distance from PA into PB is exactly equals to distance from PA and PB. Product is exactly equals to this PC into PD. Distance from P to C and PD. Product is same. When two chords intersecting each other internally. Next, let us take two secants. One more, you can extend more. Okay, this is intersecting externally. Let be point P, same AB and CD. In this case also, distance from P to A into distance from PB is exactly equals to PC in PD. Same intersecting internal or externally, formula is same, but distance from P to A again from P to B is exactly equal to distance from P to C and PD is same. Next one, tangent and chord you can take. Okay, this is the tangent and one secant intersecting is. So this is the T P. Let it be A and B. In this case, distance from PA into PB is equals to PT square. P to A into P to B is equals to PT square. Okay, these three properties will apply to solve the basic questions in this. So let us see here this problem. Okay, for example, this question number 2. You observe here. In question number 2, this is the P, A and B. This is CD. Now what is given? This is second property, right? Distance from P to A, that is 7 into distance from P to B. 7 plus X is equal to PC 6 into P to D. 6 plus 15 again. So 21 together. 7 into 7 plus X is equal to 6 into 21. You can simplify this. That is 7 ones are 7, 3. Cancel, no? Then 7 plus X is equal to 6 into 3, 18. Then X is equals to 11. X value is 11 it is. So just only properties are applied. Next, okay, question number 4. This intersecting internally. This is AB and it is C and D. So distance from PA, PB. So 10 into 18 is equals to 12 into X. We can simplify this property. That is X is equals to 10 times 18 by 12. This is 5 and 6, 2 tables, 6 1 is 6 3 is so X is equal to 15. So any property can apply in the same way. Just for example, okay, this first problem, this is T, P, A and B. So tangent and this secant. So according to the formula, PT square is equals to PA into PB, right? PT square, that is 45. 45 square is equals to P to A is 27 into PB is from here to here, 27 plus x. So you can simplify this from this you can get x value. So 27 plus x is equals to 45 into 45 by 27. Take this side. You can go for cancelling. 9 5s are 9 3, right? Again 3 times 15. So 27 plus x is equals to 75. Then x is 75 minus 27. So you can subtract, right? So only properties I am explaining. The main thing is the basic rules. These are the three basic rules regarding tangent and secant. So based on this, I am giving the worksheets. So many problems are there in the worksheets. You can practice each and every problem for practicing purpose. You can use the worksheets to improve the basic skills of this tangent and secant to the circle.